All right. Welcome. Thank you all for joining us this evening. My name is Laura Buska. I'm Solar Oregon's program manager, and I'll be sharing the basics of solar and storage and how resiliency is built into solar systems from the viewpoints of both residential and large-scale projects. I'd also like to introduce our guest speaker, Mark Farrell, who will provide a viewpoint from the residential perspective. If Mark wants to come off mute, introduce yourself.
Sure. Yeah, Mark Farrell. I've been in solar and storage for over 16 years now, mainly on the installer side, but I've also worked for a manufacturer and a distributor. And I have solar and storage at my home here in Beaverton, and we're going to take a look at that later.
Thank you. So, thank you, Mark. Thank you, everyone, for being here with us today. And without further ado, let's get into it. So, Solar Oregon is a 501(c)(3) nonprofit. We've been working to encourage the adoption of solar and storage throughout Oregon since 1979. And we do this by providing reliable and impartial consumer education, a lot like workshops just like this. We're working to build the clean energy community and performing outreach and some policy advocacy. And we also facilitate solar tours and zero energy showcases, do panel discussions on a range of topics related to solar. We also work on a solarized campaigns. Those are regionally focused short-term events where you can access solar discounts by going solar with your neighbors. And you can learn more about us at our website at www.solaroregon.org. And we also welcome you to connect with us anytime with questions or ideas for collaboration. Now we'd love to get to know who you are. So who is joining us at this event? I'm going to put out a poll here so that we can better get to know you. And I'm going to restart this 30-second clock. Okay. Thank you to everybody for sharing your information. So let's start with the basics. What is energy resiliency? It's the ability of energy systems, things like your grid and your buildings and even whole communities, to prepare for, withstand, and recover quickly from disruptions like extreme weather or power outages. And so solar resilience would be the same, but from the perspective of your solar system during a grid disruption. So power outages can vary in their causes and how frequent they are and how long they're going to last. So frequent short outages, they're usually caused by things like squirrels or storms, and longer outages can occur from natural disasters. And some areas in summer months, we have long-term outages due to red flag weather conditions, that's high fire danger. So during these times, utilities will do things like perform a public safety power shutoff where they intentionally turn off whole sections of the grid if they think their power line infrastructure would pose an unacceptable fire risk. So the first event of this kind in Oregon actually occurred in 2020, and these events are expected to increase as fire danger increases. And then, of course, we have here in the Pacific Northwest, we have a unique risk of a large Cascadian earthquake. So when this event occurs, it's thought that power may be lost in the Willamette Valley for up to 6 weeks. On the coast or the rural parts of the state, it could not be restored for several months. So Oregon's Office of Emergency Management encourages everyone to be 2 weeks ready. So you're prepared for on your own for a minimum of 2 weeks in the event of something like this occurring. So it's important to know what type of outage maybe you're expecting so that your contractor can help design a system to meet those needs for you. So, little 101, this is a diagram of a grid-tied home solar system. Grid-tied means you're connected to that local utility, like the house in this diagram. Sunlight's going to strike that solar panel or a photovoltaic panel. It's going to produce a voltage of electricity. That's a special kind called DC, and it's different from the AC used by the lights and appliances in your home. So we have another special device called the inverter, and that inverter is going to convert the DC electricity into the AC form that's used in your home. Um, and then from the inverter or the microinverters, the electricity flows into your electric panel or your breaker box, and it'll feed all the circuits in your home. And there it can power your lights and appliances, charge your electric vehicles, all that good stuff. So when you have a grid-tied system, there is a special bidirectional utility meter installed, and that measures the flow of electricity in both directions. It's going to measure the energy you send out and export to the grid and the energy you pull from the grid. And if your solar system is producing more electricity than you're using, that excess energy flows out of your home and into the grid where it can be used by other homes. So at moments when you need more electricity than your solar is producing, you can purchase it from the grid. And this meter allows you to do a system called net metering here in Oregon, which gives you credits for that electricity you export to the grid. So it's a really simple setup. But I don't know if you noticed what was missing from that system. It's a battery. And that's how you get your resiliency. Solar on its own is not going to maintain power when the grid is down. No matter how bright that sun is shining, it is not going to soak, your panels cannot soak it up to create electricity when your grid is not working. So, and it's a safety issue. Your solar system is automatically shut down when the grid goes down because we don't want power feeding back into the grid when utility workers are working on it. So it's a safety for them. There are only systems with specific battery backup that will continue to function when the grid is down. That's how you're going to get your resiliency. This is me next to a Tesla battery at a local installer, so you can kind of see the size of that one. Get an idea. It's really important to set your expectations properly about what a battery can and cannot do. Some batteries will not allow for power when the grid is down, and others will. So it's important to always, always, always ask your installer what features your battery has and what it can and cannot do for you. So some residential batteries are grid tied, and that can include that built-in safety feature to anti-island you so that people cannot be hurt when the grid's down and feeding that electricity. So that works great for somebody who wants their battery to make it cheaper for them during time of use. So if you're in a time of use program and you have, there's times of the day when energy is more expensive and times of the day when it's less expensive, you can store up energy in that battery and then use it at those peak times to save money on your utility bills. But if you want a battery that can support power to your home when the grid is down, it needs an automatic transfer switch that can go into island mode. That's going to mechanically isolate your home from the grid when using a backup source, so your electricity doesn't get backfeed into those utility lines, like I was saying. And then having black start is important because once if your outage is prolonged, the battery may drain completely and it allows your system to restart from a completely dead state during that outage. So once the sun rises, that battery detects incoming sunlight and it uses that tiny reserve to wake up the system and kind of trick your system into thinking that the grid is back online. So they'll begin producing that power and sending access to recharge that battery. But if you don't have black start and you consume all your stored battery power overnight, that inverter is going to shut down entirely. And when the sun comes up, the system can't turn on because it needs that wake up, a jolt of electricity. It's also important to think about how long and what you want to support with your battery. So a single battery is most likely not going to cover your entire home for a very long period of time. A battery is going to allow some of your circuits to remain in power during something like an outage, and that's called partial home backup. So in a scenario of partial home, certain circuits will receive power from the battery, but the rest of your home will lose power during an outage, and that'll allow you to keep your VIP things running, like your fridge, your safety lighting, maybe you have some home medical gear or something like that. On average, one battery can run a home for a day, depending on energy use and the size of the system. It's going to be very personalized to you. So that's why it's a very broad average. But if you're preparing for an extended outage, you'll need multiple batteries to store more energy. And if you're able and willing to front the extra cost, you can do multiple batteries to achieve a whole home backup. The idea is to think of a battery like buckets and then your panel like a faucet. So whether you have one battery or 10, they're all going to fill up at the same rate dictated by the clouds. You're not going to capture more, but you're going to distribute that sunlight across a larger storage capacity. So while your recharge rate's the same, your resilience with the second battery increases. So let's say you use a 5 kilowatt hour of power overnight and you have a single battery and it's nearly empty and now you're like racing to get enough sun to fill that battery up. But if you have two, that same 5 kilowatt usage only is going to drain half your capacity because you've stored more energy in that second battery. So it kind of gives you a more buffer of time before your system shuts down. Partial homes are usually about one battery. A whole battery can be two or more. But really, again, it's really important to speak with your installer so you understand what capabilities you will have with your system. So partial home backup, your home's going to be divided into sections that are backed up and sections that are not. So when you've selected which circuits you want to receive power, your contractor will remove these from your breaker box and put them in a new essential loads panel, and that's going to be wired to the battery. And there are new technologies called smart electrical panels. They provide customization and flexibility. You can have an app on your phone and allow to see how much power each appliance is consuming at any given time, which is really cool. And it allows you to turn off and on breakers from anywhere, allowing you to manage those loads and choose your preferences. So that can reduce your energy during those peak utility hours as well. And then during an outage, it can automatically shut off that heavy load circuit to preserve the battery life so you can run essential loads longer. Addition, like Black Start, that works as an essential load on the essential loads panel, usually rather than powering your entire home to prevent the system from overloading as it tries to boot up. So a friendly reminder too, if you have an older home, you might need to upgrade your electrical panel before you go solar. Um, Questions then coming in about what a microinverter is and how would that increase resiliency. A microinverter is a special inverter that replaces the on-the-ground string inverters. Instead of working with all the solar panels in an array, they work for each 1 to 4 panels each, and it provides the ability to shut down certain panels if they have issues, while you can keep the other ones on and running like normal. It also allows you to monitor each panel's production rather than the system as a whole. So they're really good if your home has shade, because shading one panel can actually affect all the panels. Whereas if you have a microinverter, only the panel with the shade is going to be affected. So it's kind of like creating that little mini island versus one large system. So that's going to build that resiliency into your system setup because it allows you to easily add more solar panels at a later date. You're not constrained by the limits of something like a string inverter's capacity. So when you're choosing a battery, there are many options. Contractors are often specializing in specific brands, so it's recommended to get quotes from multiple contractors that can help you compare your battery technologies and pricing. It's really important to note that you can't mix and match battery brands because they often have different battery chemistries, but some manufacturers offer different size models that can be combined. The next thing to think about is what features in your home you want to power during an outage and for how long. Items most frequently chosen to back up are things like your refrigerator, lights in common areas, a couple of outlets to charge something like a laptop or a cell phone. And then for standard household electrical loads like lights and appliances, many batteries will perform well for you. But if you're intending to use it to back up a load that requires a lot of instantaneous power, like a motor, they may need to factor that into the system as well. It's also a good idea to take into account what sort of energy consumption needs you'll have in the future, such as purchasing an electric car soon, if you're having a baby, if you're installing a hot tub. These are all things that that contractor is going to want to know so they can factor that into your system so that you're not creating a system that's based on too little energy or too much. And then we obviously don't want to add solar panels later on if we don't have to. So if you want power when the grid is down, you need to ask your installer what features your battery has and ensure there is the features of the automatic transfer switch and that inverter battery system with Black Start feature. And if you want to include battery storage when you install your solar system or not, that's going to affect the price. Installing solar and battery at the same time is going to be a cheaper due to labor way of doing things than if you do them separately. Um, so it's kind of there's like one or another way. The answer is like it's designed in a very custom way to fit your needs, and the components are selected to match one another as closely as possible. So it's flexible, but that flexibility during the initial design, meaning adding any new things later, can be more expensive. Um, so, and in fact, it can be up to like $10,000 more expensive. So it's usually good if you do that at the same time. Last thing to note is where is that battery going to be placed? They need a dedicated space, ideally near an electrical panel, often in the garage. And if the space is tight, they can go on an exterior wall. But per code, batteries cannot be installed in crawl spaces, cupboards, or confined areas. Things to think about. While that may all sound great, you may be asking, why should I be considering this in the first place? And how will adding solar and storage, how much will that cost me? So this graph is from the US Energy Information Administration showing the why. It's that average price of electricity for residents going up since the 1980s. Through Energy Trust's solar calculator, you can view options side by side to compare scenarios that impact your electricity costs in the near and long term, which can help you get you an idea of options and a very baseline idea of what quotes might look like for you. So you provide your address, that'll kind of have your rooftop characteristics and your electricity use and your rates. You provide them with that, and then you can apply cash incentives to compare scenarios, which is really cool. So this is an example. I used my address and I found that installing solar would provide me a very nice savings. And then I have a great cash incentive, and it shows me how much carbon is going to be reduced and how those resources, other resources that would be equivalent. And then it provides the next step to take, which is really neat. And some other key results that it can share is things like lifetime savings, when you're going to break even, your average monthly expenses. But please keep in mind that I used my apartment, and my apartment is from the 1920s, and we would need to update our electrical just to even go solar, probably also our roof. So this isn't captured in this quote, right? So this is a very basic, non-complete overview, but it's a really good place to start, and it's a useful starting place to start off. So you can play with this tool using the QR code or that corresponding link. It'll be on the next page as well, I believe. So another reason to go solar and storage, it increases your resiliency for everyone, not just you. But on a residential scale, you'll have that continuous operation of critical services during an outage, essential backup power that recharges daily, which will allow you to stay home and shelter in place if needed. And then you can also ease disaster recovery because then first responders can focus on community members in the most need. Unlike traditional emergency generators, too, solar and storage systems do not rely on fuel deliveries. So they provide a self sustaining source of energy during storms, floods, or other disasters. And in the larger picture, it reduces your dependency on the main grid because you're utilizing local power during high demand events like heat waves. So the burden on that infrastructure is reduced, and that reduces brownouts and blackouts for everyone. A really good example of this on a large scale is the PAE living building. It's the first developer-led living building and one of the largest commercial living buildings in the world. It's in Portland's historic Skidmore Old Town District, and it's a five-story mixed-use project, and it meets the world's most rigorous sustainability standards, which is really cool. It is designed to last 500 years and achieve net zero energy. It supplies all of its energy through on-site and off-site solar arrays. PV panels on the roof and dedicated off-site roof allows the project to produce 100% of its own electricity. They have an accordion panel roof design at the top that you can see, and that allows them to harvest sunlight all day long. And then it allows them to kind of maximize that gradual curve of the sun instead of just having a large spike during the midday. They have an on-site battery storage, which allows the building to run on battery. And it uses a microgrid control system to manage the power flows through the batteries, the loads, and the grid. It sets a new precedent for solar in downtown areas. It's a benefit for enhancing the residency and for all the building operations. They estimate that that building could operate for 100 days without grid power, which is wild. That is so cool. Um, and it aligns with Portland's 2050 goal for 100% renewable energy 3 decades ahead of schedule. So if you're near downtown Portland, that is a neat place to check out. Now I'm going to turn it over to Mark to share what resiliency looks like on a residential scale. Take it away, Mark. You're on mute.
Thanks, Laura. Really appreciate it. All right, everyone. Yeah, let's take a look. Let's get take a look what a system really looks like and some thoughts, some slightly deeper thoughts about how to think about resiliency, what you should need to know really about how to go about it. So what you're seeing here is my home in Beaverton. Photo number one is the solar array on my roof. Number two is some of the equipment on the side of the house. Number two on the left is the DC disconnect. So if that's a fire safety thing, so firemen can turn that off and the DC shuts down right away. Because the thing with solar, if the sun's out and things are connected, it's just going to keep making power even. So you got to shut that off. Just on the right side is that's the service coming into the home on with the meter, as you can see there, and there's in red or diagrams about the system. Again, it's a safety feature. That panel on the right of the meter is my unprotected loads panel. We'll take a look at that later. Actually, number three shows it right there. And what if you? It's kind of hard to see, but uh, those are circuits that I don't have protected. They're not backed up during an outage. Yeah, that's it. Thank you, right there. And that's my dryer and my oven. And I think that was it. Dryer and oven. That's the two big electrical loads I didn't want backed up. There's an extra circuit in there, as you can see, for future use. Number four is all the equipment on the other side of uh, the um, uh, the service in the garage, showing the battery, the main service panel, and some other equipment. We'll take a look right now. Yep, if you could go to the next slide, please. So on the wall in the garage is all the equipment that we need for solar and storage. Number one is the inverter. Laura mentioned the inverter that is taking. So I have that's a string inverter. So I have DC power coming from the roof into this piece of equipment. It inverts it to AC, and that sends it over to number two. That's the backup unit interface. That's basically the brains of the entire system. That's got the automatic transfer switch in it that cuts off the grid when there's an outage. It tells everything what to do. And I've got some monitoring snapshots. We'll take a look at where that is in the entire system. Number three is the battery. That's an LG Chem battery. And that's 9.8 kW of capacity. Um, excuse me, 9.8 kilowatt hours of capacity. That's the total energy it's got in there. And number four are all the loads in my house that can be backed up. Let's go to the next one. Yeah. Okay. So that was all the equipment, but what I find really interesting is this is the monitoring that I have. Comes in, it's an app on my phone, it's on my laptop, and because of what I do for a living, I look at this every day, and it's just fascinating. One of the things, before we actually talk about each individual screen here, one thing I really want to make sure that I drive home is that it's critical for you or the installers to understand the power demands of your specific home. As Laura said, all homes are different, and the way we use power is also very different. During an outage, it's important to reduce your power usage, or loads as we call them, mainly because you don't know how long the outage might last. 1 hour, 14 days. I mean, here in Beaverton, we had one for, I think, 8 or 9 days a few years ago. So you just don't know. And even if, some folks say, well, I'm going to get a whole home backup and I'm going to be independent. Well, you may not be, because again, you have absolutely no idea how long that power is going to be out. Because at the end of the day, I've got LED light bulbs all through the house, and they pull as little as like 10 watts. It's a small, small amount of power. However, I've also got an electric dryer, an electric heat pump, which could pull like 5,000 watts or 5 kilowatts. So that's an enormous amount of power. My battery wouldn't last long at all. So in these screenshots, what you'll see, and I'll point it out, that my load will vary anywhere from a low of about 300 watts to over 7,000 watts. So let's go to some of these screenshots. So the first one on the left. Now this was this was done recently, and I manipulated some of the equipment in my house just to show different scenarios. So what we're seeing here is a typical day. Right now, my solar is making 4.29 kW of solar power right now. And it goes, the green arrow goes down. That's the backup unit interface. That's the brains I was talking about. You'll notice all the arrows are going to or from it. That's the piece of equipment that is sending power where it should go, whether it's to the home, the battery, or the grid. At the moment, it's sending it to two places. It's sending it over to the home. I'm using about 510 watts, but most of it's going back to the grid, 3.78 kW. When you look at all these screenshots, if you add up the numbers, it's all going to make sense. Like 3.78 plus 0.51 equals 4.29. So it all makes sense. So you know where everything's going. Okay, so then a little bit later, we had a grid outage. That's that middle screenshot right there. As you can see, the grid's down. There's not an arrow going to it. There's not an arrow going from it. And right now, I turned on the heat pump. I turned on the electric dryer, and I'm using 7.6 kW or 7,600 watts of power. But my solar is only making 6.22, which means the battery is going to turn on and discharge in, into my system to continue powering what I have in the home. A little while later, I turned off some of that equipment. Of course, I'm making less solar at the moment. I'm only making 3.91 kW, but my load is down to 3.02, so that means I'm going to go fill up the battery. And that's why you see the green arrow pointing down. With the middle one, the green arrow was pointing up from the battery, meaning it's discharging. But here it's pointing down, and you can see there's a little symbol in the battery showing, hey, it's charging back up, which is great. Let's go to the next one. Okay, so here in number 3, so the grid is still down. Solar power is going to the home, but it's also coming from the grid. And as you can see, you've got 1.12 kW from solar, 0.09 from the grid, because the home is only using 330 watts. So all I've got on now are a couple of lights, my router, and some phantom loads. That's it. Notice the green arrow going down to the battery. The reason that charging arrow will always be green is that I can only charge my battery from solar. This is a requirement from the utility. They only allow it to be charged from solar unless you have a special deal with them, and we'll talk about that later. But your typical solar and storage system, it's only going to it's only going to recharge from solar. And again, if you add all those numbers up, it's going to add to 1.12 uh, kW. So it's all going to balance out. In the middle, oh, by the way, back to the left-hand side there, you'll notice going to the home, that arrow is striped. It's green and orange, showing we're getting power from both sources. The one in the middle, let's see. So here, again, the grid is still back on. Uh, we've got solar power that's even less at the moment, but still uh, showing that green arrow going down because again, you can only fill your battery with solar energy, not with the grid. That's what that's showing. Now, what's important here is notice to the home, that's a solid orange arrow. So there's no solar going to the home because the system knows, the brains know, well, I want to fill up this battery as soon as possible. I'm going to take all the solar energy and put it in this battery, and the grid is going to power that 220 watts. Boy, I must have turned something off. That's really low. 220 watts. There's not much going on in the home. But the important part of there is seeing the difference between the left slide and that middle slide, so that you understand it's only coming from solar. So the one on the right, what we're seeing is uh, the grid's up, so the sun's out, the load is still quite low, and now we're sending power back to the grid, and we're also continuing to fill the battery. When we send power back to the grid, we're net metered, meaning we get a one for one credit from the utility to send energy back into the grid. All right. Do we have one more? Or yeah, okay, great. I wanted to mention a couple of other things of my system. It's a 7.68 kW. It's got 24 modules up there. Um, and it is 6.5 years old. So I've got lots of data, which allows me to really understand what my system's doing and how to prepare for the future. You'll notice that it's all in the garage, all the equipment on photo number 4. Today, most people are putting those batteries outside, which is absolutely fine. Um, you always have to be careful about not putting it in a very sunny spot. If you've got a south wall, that's the best. East wall is second best. West wall is a possibility depending. But again, your installer will be able to help you with that. When you get quotes from different installers, they should also be able to help you with that load profile, meaning they should be able to sit down and say, okay, let's take a look at what you would like to have powered during an outage so that they can understand if they should propose one battery, two batteries, or three batteries. I've only got the one, so I have to be very careful during an outage. I've yet to actually run out of power, which is great. However, my battery does have uh, 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 the black start capacity, meaning let's say the grid's down and I'm very careful about using power, but it gets down to 15%. Now I've set my battery at a minimum of 15%. I don't want it to go any lower. To have a black start, what that means is when the sun comes out and the grid is still down, my system will pull some power from the battery to start it back up. And the reason that's important is because when you have a typical solar system in your home, let's say no battery, the reason your system starts up as soon as enough sun comes up is it takes a little bit of energy from the grid to like crank it up. But with the battery and having a black start capacity, I don't have an issue with the grid being down because if it didn't have that, the grid would be down and my system would still be out. But most home battery systems have that capacity because the point is that's what people want. They want to be able to have power when the sun's up, even if the grid's still down and their batteries is low. Let's see, what else do we have here? That's pretty much what I wanted to talk about. Laura, are there any questions in the chat?
There are. We have, what about SMA Sure Power Inverter does not need a battery? Do you know about that?
I, is that the one I'm thinking? I think I do. Let me just, because they used to have, they used to have a certain type of inverter that it had an outlet and no battery, just an outlet. So when the sun was out and the grid was down, you could actually power something, maybe, depending on how big the load it was. But that's kind of gone away. Sure power. That's yeah. I don't know. I don't really know about that. You might have to ask about. I mean, it sounds like it might be some sort of a UPS, like an uninterrupted power system. And yeah, I mean, that's an old way of powering things with a real small battery for a short period of time and a very light load, like your computer, for example. Um, and Laura, who's the man? Oh, there's there's Ed.
Well, I
Uh,
figured
yeah.
He's
I
got
would.
to know.
Can you guys hear me?
Yes.
Yeah.
I don't know.
Oh, okay.
Sorry. I'm not an expert on that one.
Thank you for trying. And then actually, the next question came from you, which was talking about AC versus DC coupled batteries and high voltage DC versus low voltage DC batteries and the difference between things like upfront cost, features, scalability, upgradability, etc.
Well, let's see. So my battery system is DC, meaning um, I, I've got DC coming from the roof. It's going directly into the battery. An AC coupled is basically you have an AC coming from the roof, so you got microinverters up there, and you have to invert it to put it into your battery, and then you have to invert it back again for use. I don't have a lot of data on which, I mean, people debate this for years. I've been doing battery and solar storage since 2018, I guess, and people go back and forth with this all the time. Some people think it's more efficient just to have a DC coupled. Others say, well, the AC coupled might be a little bit less expensive. Ed, do you have any thoughts on that?
Yeah, I think it boils down to whether you're starting a system from scratch or whether you're trying
Mm,
to, after the fact that, if you had solar installed 5 years ago, you didn't plan for batteries, but now you suddenly, because of this webinar or some other resource, now you want batteries. Um, what can you do? And so a AC coupled battery is easier to retrofit into a home that uh, had a solar inverter and a solar system installed in the past. If you were to um, design a system right now from scratch and you wanted to have both batteries and solar installed at the same time, generally, the current market trend is that a system that has DC coupled batteries is going to be more cost effective. And then also perhaps in the future, like right now, let's say you have the budget for like a 10 kilowatt hour battery, but 2 years later, let's say the batteries get much cheaper, and you're like, whoa, I have some spare change, and maybe the grid's reliability is maybe getting worse, maybe because of data centers or something like that. And now you want um, more batteries just so you have more resiliency. So how do you upgrade and be able to add more batteries? A DC coupled system will be able to let you upgrade the more storage with less cost down the road.
that's great. Yeah, I appreciate that. I would agree with all that too. I hadn't thought about that for this presentation, but that's a great point as far as new systems versus retrofit.
Hmm.
Thank you for hopping off and sharing with that. Um, and if and nobody, I don't know if anybody knows, but Edward is on our board and he is a reliable source of knowledge when it comes to all things solar. Um, and then we have I have that type of inverter. Okay, so the same, so Bill, he asked about the SMA Sure Power inverter. He said he has that type of inverter and it only works if there is sun,
Yeah, yep,
which would make sense.
yeah. That's yeah, it's a secure power supply inverter. I think it's what they used to call it. They must have rebranded it since I saw it. Um, what was it? What was it? The audience member's name again? Who has that?
Bill,
Bill. Uh, any comments, Bill, on how useful or not that's been?
I will, I will allow Bill to talk. There we go. Hi, Bill. Go ahead and take yourself off mute if you'd like.
Um, I have several inverters, but one of my inverters is a Shore SMA Shore inverter, and it's made to work. If the grid goes down and there's sun, it makes its own sine wave.
Hmm.
So most inverters, grid tied inverters, if you know what phases are, it matches the phase of the inverter with the phase of the utility. So that's what grid tied is. You're matching the two phases together so you don't have electrical problems. With the shore power, it makes its own waveform. So therefore you don't need a battery, but you don't have storage. So at night you get nothing. Okay, so if you want nighttime operation, then you need to have batteries.
Mhm. Right. Great.
Thank you,
Thank you.
Bill. That's great. Um, and then Edward, he has also mentioned that we need to ask your solar contractor how much power you can use at any moment during a power outage. So on an Enphase system, the IQ Battery 10 provides 10 kilowatt hours usable energy and up to 7.08 kilowatts of continuous off-grid backup power, excuse me. Your Tesla Powerwall 3 will integrate 11.5 kilowatt continuous inverter and a 13.5 kilowatt hour usable battery into a single unit. And then the Solar Edge Home Backup Interface acts as the system's microgrid connection device, and it only has a small auto transformer, a 5 kilowatt auto transformer, providing a split phase balancing to accommodate heavy loads like 120 volts on a 240 volt system during grid outages.
Right. And
Thank
that's really important if you, like you say, it's like as Edward said, if your startup uh, power requirements, especially for AC units, heat pumps,
you.
um, it's really key to really make sure that you understand that and match it. Luckily, that startup is is coming down. My heat pump's new, and I can't remember what I need, but I do know that when I during an outage, the heat pump, well, it works as an AC unit in the summer, of course. It will turn on. You can tell it's gonna you can tell it's turning on because everything dims briefly, but there's enough power there for it to crank over, over that motor, and then of course it decreases right away. But
I'm
again,
gonna, I'm sorry.
no, I'm sorry. Again, your installer really needs to take a look at that and understand that to make sure they're designing the system correctly.
I'm going to quickly launch the poll one more time because it should go on for a little longer, and that way everybody can actually. So we're going to relaunch this. Okay. This helps us understand who's coming to our events, what kind of things you want to see. It helps us with our promotional aspects and things like that. So if you don't mind taking a quick second to do that. And while we wait, if you're curious about solar and storage and you want to learn these, the next steps in this journey, how to have some financing options or local incentives to reduce your costs, you can join us for one of our monthly How to Go Solar and Storage webinars. We do them every month, different days and times, so that we can try to reach as many people as possible. The next one's scheduled for July 7th at 5 p.m. You can use the QR code or links to register for that. And then if you're ready for some quotes and you're like, I want some quotes from installers to get some solar up on my roof. This is the Energy Trust of Oregon, and they have trade allies that are going to be contractors who are kind of at the top of their game. And they're the only contractors who can provide you with incentives from an Energy Trust, which are thousands of dollars off. So this is a great place to start. And you might be wondering how you can advocate for any energy resilient projects, I'm sorry. Here's a few ways you can get involved. Advocating, every school should go solar, and the Portland's public school system has actually pledged to reduce greenhouse gas emissions by 50% by 2030, and net zero emissions by 2040. So if you have kids in school and you're involved, or you get involved in the school board, that's a great place to start. You can do the same with neighborhood associations. You can advocate for solar friendly policy at the state and federal level through campaigning. We're happy to assist you along the way. I'll welcome you to join Solar Oregon's policy committee, or you can become a volunteer for events, promotions, admin tasks, fun things that keep you connected with this community. And if you can't support with your time and you can support with your dollars, you can become a member or a donor to Solar Oregon to help support our work. And we thank you for joining us. Love to stay connected. This has both of our emails. You are welcome to reach out. We are here to help you on your solar journey. If you've got extra questions that we weren't able to answer tonight, please feel free. And we hope to see you at some events in the future. Thank you all so much. We'll stick around for a minute. We have, I think, one more in the Q&A. Currently, an EV vehicle to home capability setup is not a cheaper, inexpensive system to implement. In the future, that might change. I hope so. Edward keeps very good view on what the market is doing with any given thing, and he runs our green energy series. So we were able to learn a lot about how batteries are becoming much more affordable. So if that's something of interest, it'll be on our YouTube page, Solar Oregon's YouTube page, if you're interested in hearing more about batteries and their affordability. Wealth of knowledge. Thank you, Edward. And thank you, Mark, for sharing your solar system. It's inspiring. It makes me want to buy a house and put solar on it tonight. So
My pleasure, Laura.
thank you. Thank you all for joining us.